So just some practice with notation again. This Z means that we're looking at a standard normal distribution. So standard normal distribution always has a mean of 0 and a standard deviation of 1. And that's what it says here. Right here, this is our mean, and this is our variance, which is our standard deviation squared. So a little reminder of that notation. And what they're looking for here in this first one, it says, find the probability that your Z-score is less than 2.68. So as far as a picture goes, you could draw your bell curve like you would normally. You could label your mean. In this case, since it's a standard curve, your mean would be 0 and go up 3 standard deviations and down 3 standard deviations. And since your standard deviation is just 1, it just is 1, 2, 3, and -1, -2, and -3. Then if we want to find that percentage, we're going to go to our calculator, just a reminder on what we need to do for our calculator. And anytime you're trying to find a percentage, you're going to use normal CDF. So if we go to our distributions, which is second vars, the second one is your normal CDF. We want to go from a big lower number, so -1 times 10 to the 99, that's probably big enough, up to 2.68. Our mean is 0 now. Our standard deviation is 1. And we can paste that in and find out there's a 99.6% chance of that probability. So again, our calculator is doing most of the math for us. And that can make either probability and, when we get into statistics, really easy if you know how to use your calculator, or it can make it really hard if you forget what you're going to do. It's not like it's something, if you're one of those math students that doesn't study a lot and feels like I could just go into that test and figure things out, these units are hard because there's not a lot of figuring out, because you're using your calculator to get a value that otherwise would be quite hard to calculate by hand. So in the second one, same kind of idea. Draw a picture. The nice thing about drawing a picture is it should give you a sense of what that percentage should be like. This percentage should be bigger than 50% because it's more than half of the bell curve. Again, if we go to our calculator, now -1.41 is our lower one. We can put a huge number in for our upper one, same mean and standard deviation. And we've got a 92.1% chance. Again, just notation-wise, a Z-score is how many standard deviations above or below the average something is. And that's when we have a standard normalized curve. All of our scores are called Z-scores, which is counting how many above or below the mean you are. So a -1.41 means you're exactly 1.41 standard deviations below what the average was. And this notation here is telling us we want to find the probability that your Z-score is bigger than negative 1.41. And so as far as shading it, the area of the shaded part is that probability. And the normal CDF calculates that for us. So here's the last one. Again, this is a nice one because it says in between two values. I'm not going to draw the picture this time. I'll just think that you could put that into your calculator, draw a picture, and be fine. So if you want to check later if you got this right answer, it is 0.377. So far we've used normal CDF. That is one key thing that we have. And a normal CDF will always find the percentage. It'll always find the area under that curve. So a lot of questions say, what is the probability that the score is above this or the score is in between? All of those questions are normal CDF questions. The next type of question is sort of working backwards. The first one, we knew the scores, we wanted to find the chance, we wanted to find the probability. Now we're going to have questions that say, here's the probability, what scores would do that? Okay, so if you have, we're going to get some questions like, I want to give out a scholarship to the top 10% of students in a class. And their scores are normally distributed with this as a mean and this is a standard deviation. What score should be the cutoff? That if you get above this score, you get that scholarship, below that score, you wouldn't. And so these kind of questions, you are given the percentage, and now you're going to find out what the score is. So again, I'm going to draw a picture of this one. We've got our bell curve. We know that our average is 60. Up 3 standard deviations, down 3 standard deviations. What score would separate the top 10% of the class? So somewhere in here, there would be a line. And this is where, if you're drawing a picture of it, sometimes the 68, the 95, the 99.7 rule can be helpful, because if I know that this is 68, that's going to be 34 and 34. And 68 to 95 is another 27%. So this would make this approximately 13.5% and 13.5%. And then the last 5% has to be split between these. So this will be, these two together will be 2.5%, and these two together will be 2.5%. And if you wanted to use the 99.7 in there, you could even say, okay, I'm going to estimate this to be 0.015 and this to be 0.015, so this is 2.35. Just give you a sense of what the percentages are. So where would the top 10% be? Well, it would include all of this beyond here, all of this one, and it would somewhere be in there as far as an estimate goes. And so we're looking for that score. What is this value right there that would separate this so I have this part equaling 10%, 10% of the area. Now our inverse norm function, the way that it's set up in your calculator, it always calculates areas from left to right. So even though we're trying to find the top 10%, if this is the top 10%, there's 90% to the left of it. And the inverse norm always comes from the left. And the way we put in our values is we put in the percentage here, our mean here, and our standard deviation there. Of course, with the newer calculators, when you go to calculate inverse norm, which is right under normal CDF, it asks you all of these things right away. So I want an area of 90% because I'm coming from the left. My mean is 60. My standard deviation is 7. And then it pastes it in there for you in the right order. And so we get 68.97. Now rounding that to 3 sig figs, you'll round it to 69.0, and you would need to put that 0.0 in there so that you have 3 significant figures. So the first important thing for this inverse norm that we have to know is it's always calculating the area from the left. So you're going to have to do a little bit of math figuring things out. Like this one, we had top 10%, so we had to figure out from the left. 90% would be left. I've added a part B here to this question. What happens if they ask for the middle 50%? What scores would you need to? How would you draw that out? So again, I have this same 60 there, 1, 2, 3 above, 1, 2, 3 below. Since one standard deviation is 68%, my 50% will be somewhere here to here. What are those values? And I need this part to be 50%. Crayon. There, nice fall color. So pretty. Okay. So now if we're always going from the left, this time we're going to need 2 scores, right? We're going to need this first score, and we're going to need that second score to find out the scores that create the middle 50%. What value will we put in for the first score? 25. And the second one? 75. So our lower one, that's what the L stands for there. Our lower one is 25% away from the left. Our upper one is 75% away from the left. And so those scores would be 55.3 to 64.7. More stuff with normal distribution. So here's our standard normal distribution, and there's a formula for how the Z-score is calculated. So we'll do a simple calculation here just to figure things out. Okay? We'll pretend we'll talk about grade 12 provincial exam. Let's say the provincial average last year on grade 12 provincial exam was 65, and the standard deviation was 8. And you scored a 73. No, let's not make it 73. 73 is too nice a number. Let's say, well, let's say 73 is not nice enough. You scored an 85. That's even nicer. So how do you compare to the rest of the province? How do you compare overall? Where are you at? So what your Z-score does is it calculates how many standard deviations above or below the mean you were. So for this one, are you above or below the mean? You're above by quite a bit, right? You're 20 marks above the standard deviation. I mean, above the mean. If we want to figure out exactly how many standard deviations you would be, can you see that you are more than 2 standard deviations above the mean, but less than 3? So all this formula does is it calculates that. Our score was 85. The average was 65, which makes you 20 above the average. If the standard deviation was 8, well, 20 divided by 8, your Z-score would be 2.5, and that stands for 2.5 standard deviations above the mean. So that's all a Z-score does. The nice thing about this is we can use, sometimes we're trying to find things that we haven't found so far. Like we haven't had any questions that have asked us to solve for what is the standard deviation. And so here in our next question, we've got an example of certain kind of TV is normally distributed with a mean of 8 years. So you buy this TV, you can expect it to last 8 years. They find out that the chances that it will not last 5 years is 5%. So as far as drawing our picture goes, this is the information that we're given. Got a bell curve because it's normally distributed. So anytime you have this in a question, it's telling you that it makes that bell curve, and it's telling you you're going to need to use either inverse norm or normal CDF. We know that our mean is 8, and down here at 5, we know that this percentage, that it won't last 5 years, is only 0.05. And we want to find our standard deviation. Now, when you go to put inverse norm into the question, the problem is you have to type in the percentage, the mean, and the standard deviation. And we don't have that. We've got a percentage and we know the score, but we don't know the standard deviation. But what we can find, and I'm going to draw right underneath this, the same curve, the same crayon, the same 5%, but I'm going to look at a standard normal distribution. In this standard normal distribution, what do I know? I know what my standard deviations are because I go up by 1, right? But I don't know the score, my Z-score, when it's a standard normal distribution. Well, using this, we can find that score because our inverse norm, that finds scores if you know a percentage. Coming from the left, do we know, so second vars, number 3, inverse norm, we know the area is 0.05. And if we're using a standard normal distribution, we can put in that our mean is 0 and our standard deviation is 1. What this is going to calculate for us is our Z-score. So we have inverse norm, 0.05, 0, and 1. And we got from our calculator that that's negative 1.64. That's our Z-score. That's this value right down here. And that tells us that this value 5 is 1.64 standard deviations below the mean. Once we have that value, we can say, well, I know that my Z-score is always my actual score, subtract my mean, divided by however many standard deviations we have. In this case, I know my Z-score, I got the negative here, is negative 1.64. No problem. Okay. Negative 1.64 is our Z-score. We know that our actual score is 5. We know that our mean is 8. The only thing we don't know is our standard deviation. And so solving for a standard deviation, this will be negative 3 on the top divided by negative 1.64. 1.82. So these are probably the most complicated questions if they're asking you to either find the mean or the standard deviation, and they give you some data. Almost always you'll have to go from the data you're given to put it into a standard normal curve. Because in a standard normal curve, you can find out that if it's 0.05% or a 5% chance, if it's a 5% chance, it's always going to be 1.64 standard deviations below the mean. That's what a normal distribution does, is it sets things up so that no matter what you're dealing with, a 5% chance is always 1.64 below the mean. And once you have that information, you can use your Z-score formula to find out what you're missing, which might be the mean, it might be the standard deviation. So this technique will be used to solve either one of these two things. Because if you know those two things, if you're actually trying to find the score, then you can use inverse norm directly. Okay, I'd like you to try the next one. And I'll put up the answers there. Don't look if you're not done yet, but so that when you are done, you can find out. All right, if you want to check the next one. There's your picture. So all three of these were normal CDF questions, because all of them were asking you to find a probability. So there's sort of one thing, you've got a normal distribution. If you're trying to decide what should I use, normal CDF or inverse norm, there's sort of two categories. And that's sort of recapped here, but we can sort of summarize it at the bottom here. If you're ever asked to find a probability, find a percentage, find a chance, that's always going to be a normal CDF problem. In that case, you will always, if you're asked to find a probability, they're always going to give you a score. So you're going to be given a score, asked to find a probability. And that might be a Z-score, it might be a regular score. You're going to need your mean and standard deviation. Always going to use normal CDF. Your inverse norm ones are the opposite. So when do we want to use our inverse norm? Well, now we're asked to find a certain score. You're asked to find a score, and you're given a probability. You're given a percentage, and you're asked to find a score. So those are the first two, and then we looked at that one example with the television where you were given a probability, so you're going to have to use inverse norm, but you might have to use inverse norm first to find a Z-score, and then you can find your mean or standard deviation. So if you're asked to find your mean or your standard deviation, you're going to need to find your Z-score first with the probability that's given.